In December 2016, the first commercial offshore wind farm in the USA began producing energy. Five 600 feet high windmills, each equipped with 6 kilowatt turbine, were erected 3.3 nautical miles southeast of Block Island. The island is a very popular summer destination, known for beaches, boating, and saltwater fishing. In winter, serene and quiet, with roughly 1,000 inhabitants. In season, maybe hosting up to 20,000 people on some popular summer weekends. A few landmarks reminds of the island's rich history, involving Native Americans, pirates, sailors, and settlers. Perhaps the biggest assets of the island are a rugged beauty of its coastline and rich, vibrant ecosystem. For the islanders, the beaches at Block are a big source of income, and they intend to keep them natural and pristine. Not surprisingly, the idea of a wind farm near the island divided the community. On one side, promise of cheap, clean energy was appealing to some. To the others, the sight of the windmills was an eyesore to the pristine view of endless Atlantic. The cables connecting wind farm with the island and shore were originally buried with the sea plow. Near the landing, unfavorable geological formation prevented deeper burial of the cables. When the storm and waves exposed electric cable at the most popular island beach, the community united, requesting prompt resolution of the problem. A few years of studies, couple proposals later, the involved parties agreed on the permanent solution. Rather than attempt to bury the cable deeper again using plow, engineers come up with alternative methods. By means of horizontal directional drilling deep under the seabed, the narrow tunnel will be created. Then, an HDPE pipe will be pulled into the tunnel, creating protective sleeve for the cable. Finally, the old cable will be removed, a new one sent through the conduit, and spliced with original unexposed portion of the cable. Initial approach involved two drilling rigs, one on the land and one on the barge, drilling simultaneously and meeting midway. The offshore part of the project was planned to be executed from the decks of two jack-up flexi-floats. The jack-up flexi-floats are solid platform for the inland water application, but we were offshore in the open Atlantic, approaching storm season. To achieve the proper angle of the drilled tunnel, the plan called for erection of the series of goalpost-like structures on the bottom of the ocean. The outfitting of the barges was time-consuming and tedious endeavor, while we were closing dangerously on winter storm season. Throughout the process, the shortcomings of the flexi-floats become more apparent. They were not only limited in deck space, but also painfully slow on jacking up and down. In bad weather, the limited footprint of the barge's legs may not provide adequate stability. Furthermore, on-site geological conditions rise the potential of the leg punching through the layer of soft sediment, endangering the barge and the crew. By Thanksgiving, decision has been made to replace floats with jack-up boats. While not offshore, we were staying on the island in the houses rented by the company. The so-called diver's house was the center of the entertainment in more than a few occasions. For most of the time, the participants enjoyed the festivities. Of course, some experienced difficult mornings, others troubles finding way back. One case required skilled help. Some egos get crushed, some personal limits exceeded. Surprisingly, only couple black eyes reported. Generally speaking, we work hard and long and have some fun afterwards. Of course, being on the island means an opportunity for a fresh seafood supply, which obviously we took a full advantage of. Making money on the block, we feel the need to contribute to the local economy, suffering from a COVID restriction. We frequent the local restaurants and bars, in the process meeting a lot of new friends. While we were regrouping for the new approach to the project, two jack-up boats, Ram 7 and Ram 15, were making their way up the East Coast. Ram 15, the bigger of two boats, was designated for dredging and drilling activities, while Ram 7 became the dive boat. The careful planning had to be implemented due to limited space and abundance of equipment. Every piece of gear has to be either welded or lashed to the deck to prevent movement at the high seas. 3 trailers made up the dive spread. First one was a tool shanty / dressing and drying room for the wetsuits. The middle van was divided in half. First was the compressor room, with 1 diesel and 1 electric high-pressure compressors. The other half hosted airbags. In the middle of that, in climate control atmosphere, sat the standby diver, dressed and ready for emergency. Finally, the last trailer hosted the command center, with gas distribution rack, communications, video, and double lock the compression chamber. Video system includes 2 dive heads and 4 deck cameras for monitoring diver, standby diver, and the deck operations right from the command center. Communication panel enable not only diver to surface contact, but also via ClearCom direct connection with standby diver, as well as both lars, and crane operators. Vertical transportation from the deck to the seabed was provided by double system launch and recovery unit. Two diesel hot water heaters were responsible for providing thermal comfort to the diver. Two standby air and one oxygen bank, each made of 12K bottles, provided additional safety factor to the dive operation. All that equipment were powered by 200 kilowatts generator, with 35 kilowatts being in reserve. Transportation from shore to jackup barges was provided on board crew boat Barbara Miller. When we require extra horsepower, we have Sean Miller tugboat standing by. Throughout the project, frequently, we were blessed by incredible spectacles provided by the nature. The sunrises and the sunsets on the island tend to exert uncommon range of colors. The project eventually evolved into using only one drill. While inshore, rig begins drilling the tunnel. Offshore, the first step was to establish a containment around projected punch hole. The containment, in form of a trench, is designed to keep drilling debris and bentonite restrained after the drill string punched through the seabed. The containment was excavated by the dredge pump, and the plan called for video inspection of the trench by remotely operated vehicle. It turns out that on-site conditions were too much for the Sea Otter ROV, and the diver has to be sent out. Just as we were getting ready for the diving, a study surfaced documenting presence of a great white sharks around the island. In fact, the 8 of them were pinging the receiver located nearly 1.5 nautical miles away. That definitely provides additional excitement. A couple days later, a drill head has arrived at destination point. It was time to send the diver to rig the drill string to the crane on board Ram 15.
Sound check, 1, 2.
I can hear you loud and clear, Yuri. Got me good?
Got you loud and clear. Now rest of it.
Send me through a new one.
Roger that, give me a new one. Get crabby. I got bubbles. Yeah, we're going into the stand here. Never.
Roger that. Hot pep.
Alright, so here's the drill head, right?
Come again?
That's the drill head right there.
Yeah, roger that. Come back and bring it up. Tighten up that joint there.
Keep coming down.
He's coming down on that?
Yep, he's coming down. They got movement on the strap.
Roger that. You got movement on the strap.
Right. Looks great.
Alright, that's good.
Alright, coming back.
Coming up. Coming out of my house.
The offshore drilling crew switched drill head with a reamer used to increase the drill tunnel diameter. While the drillers were busy reaming the tunnel, on shore the crew began to assemble the HDPE pipe. All the sections have to be welded together, creating 3,500 feet long pipe right at the edge of the surf. Drilling completed and pipe assembled, all that was left was waiting for a window of good weather. Finally, the day we were all waiting for arrived. On the beach, loader and an excavator pushed one end of the pipe towards the ocean. Line was passed to the tugboat, and the pull offshore begins. Assisting the tug in keeping the lengthy pipe straight was 5 jet bolts hooked to the pipe in even interval. The launching and sailing of the HDP pipe took several hours. Eventually, the shore end of the pipe was hooked and raised on board the Ram 15 to be connected to the pull head of the drill string. The next crucial phase was pulling the HDPE pipe into the drilled tunnel. After a grueling 14-hour day, the end of the pipe emerged in the shoreside pit. The actual cable replacement was awarded to the different company and scheduled for the spring. What we've got left was to secure the pipe offshore end. It was all about diving. First, we need to dig the trench for the portion of the pipe sticking from the seabed. In the next step, the actual punch point was covered by articulated concrete block mattress. Then, the pipe was cut off, leaving only about 5 feet sticking from underneath the mattress.
Little more. Little more. Little more. Little bit more. Right there.
Finally, the removable plug was placed on the end of it.
All right, now look down and look at the pipe again. Let me see if that helps. All right, now give me a look at the pipe each way. Here's pipe. Look up the snorkel, then look over to the buoy. The buoy is on the mat. Feels pretty sturdy, actually. Very nice. Here, everything's fully covered on it.
The second cable was shorter, almost half of the size of the first one. Armed with recently acquired experience, we followed the previous MOD with little changes. It proved to be a recipe for the success. By the beginning of the February, thanks to efforts of the great group of people, my fellow divers, dock builders, operators, drillers, and boat crews, the offshore part of the project was finished. It was time to say goodbye to the island.